Hi everyone, Amit here. Welcome back to my channel. I am glad to have you back. And today we're going to be diving into calculus. I have created a very short app with the help of NLP just to show you a bit how quickly you could set up a calculus application that can help you for schoolwork, basically, or just for curiosity. And speaking of curiosity, I do have this book right here, Mathematics from the Birth of Numbers. It's a historical volume. Um, basically, as the title goes, from the birth of number to basically advance advanced topics such as transforming double integrals to polar coordinates, um, numerical integration, uh, pretty much spans most of the mathematical subjects, and I highly recommend it. Great volume, and this volume actually inspired me into setting up this application. So again, everything is on my GitHub page. I will have the links to on this episode, and by the way, I just do want to apologize because the camera focus is not great on this camera. I got it like 2 years ago, and basically, I never expected to do YouTube to be a YouTuber, um, and I realized that it really isn't up to par where focus is concerned. And I do plan on getting a brand new one, one of those with the AI autofocus that also is motorized. So that is on my list to get very soon. But it is what it is for the moment. So let's jump into this because I'm excited to show you this calculus app.
All right, so here we have the code. Basically, just wanted to show you it's just got a few libraries. Tkinter, you've seen this one before in my other episodes, as well as SymPy and Matplotlib. Um, the other ones that are kind of new are uh, Pillow, so basically Pill, and that is something that improves the images. Uh, well, essentially, it enhances imaging like scripts and notations, and it's one of the enhancements in this application where notation is concerned. Um, yeah, pretty much um, the I would say Tkinter is used for the graphical elements, SymPy for symbolic mathematics, Matplotlib essentially for all the plotting functions, and um, Pillow actually helps in rendering images, uh, quote unquote, called light text as images. So basically text, and it works together with uh, it works within the graphical user interface. Um, this handles SymPy for symbolic math, and you'll see that in just a moment. So let's get this running because ideally this is a very short program. For, from what you could tell here, basically you just have 347 lines, uh, and uh, here's the optimal prompt, by the way. So this again with the code will be on the GitHub page and the links in the episode. I got my environment going here. So environment is all set up, and that is mostly used for importing the libraries. And let's get this going. I This is all created basically within the folder calculus, which is our project folder, and here we have the essentially uh, the executable, so the one that we double click and just spawns the program. Um, this is still parsing, so I'm just going to show you a bit the code here. So the breakdown, everything here is an object, and of course, if you just hover over it, this is a class, this is a method. Uh, Again, classes, methods, basically everything is designed and neatly conceptualized within Python as an object, which is, well, essentially uh, object-oriented programming. Um, Here we have the application running. So we have an area where it allows for copy paste input. It will highlight this function here, which is going to convert natural notation to SymPy notation. And if it's a derivative, we'll just click on derivative. If it's an integral, we're just going to click on integral, and it will break down the solution for us. And for most of the equations, we will get a graph. There's also a user guide, which makes things nice and simple for users. I always advise integrating a user guide in every application that you build. So let's see how this works. I have some examples here. So we have some derivatives and we have some integral equations. So let's take a derivative. Let's copy it and let's input it. As you can see, the convert notation has highlighted, and we will click on convert notation so you can see that it's converted it into a readable format for the system to understand. And because it's a derivative, we will click on derivative to compute um, the uh, the breakdown of it. So the function, and we're differentiating here with respect to x, and this is the differentiation and the simplified answer, basically. Let's try another one. So we have the clear button. We'll just clear that. Let's enter it. Again, it advises that we'll convert the notation. Well, in this case, it was a lot more simpler. It didn't need the conversion because it is a generic function in this sense, a well-known function. Let's clear that. Let's try another one. Let's choose this one. So again, derivative. Let's convert the notation. Watch what happens when we convert. Click on derivative, and this one, uh, it shows us the function, the original written function, the way it looks as a natural looking function, and we differentiate it, and the simplified answer is the differentiated one. Let's try some integrals. So let's choose this integral. Let's clear. Let's paste it. Let's convert it. And here we go. So we have the naturally written function, integrate with respect to x, and the simplified answer, and of course the graph. And yeah, pretty much, let's see the user guide. So we get the user guide that explains how to use this. And we also have some examples as well. So that's pretty much it. Um, Pretty simple, straightforward. You could use your NLP to provide you with additional uh, that you could just paste in and test and have fun with your program. If there is additions or more power that you wanted to add or changes, you could just copy paste the program, add it into your uh, gen um, into your NLP, and it will process all the information and enhance your code. Basically, you can add uh, just regular functions solving. You can create one um, for algebra as well, algebraic equations. Um, just about whatever you need for school, college, university, or so on. It's using Python essentially for solving uh, math problems, physics problems. You can create one for chemistry as well. Is a great way to go and a great way to learn programming as uh, it's more an additional way of helping you out with your essentially projects and homework. So that's pretty much it for today. And for this episode, I do hope you liked it. Um, that Throw me a line if you did. If just we'll be happy to hear from you. Um, do follow me if uh, if you can. I would appreciate it. But you're also going to, if you subscribe, you're going to be updated with every uh, every new episode that comes out, and there's a lot more coming up soon. So hope you enjoyed this one. Glad that you joined, and bye for now. Thanks for watching.